Today, Jem Rayfield is going to talk about the Ontotext dynamic semantic publishing platform now and demonstrate it. He'll discuss how the DSP platform applies various techniques to provide personalized content streams via its reusable API services. Jem is an experienced software practitioner, architect, and the director of development. He has a clear business vision, work with the business to build on it and deliver a result that meets or exceeds expectations. Prior to working at Ontotext, Jem was lead technical architect within the News and Knowledge Department and the BBC, and head of solutions architect at the Financial Times. His primary focus is end-to-end software development and delivery. Jem has also proven himself as one of the best architects of semantic technology solutions. And as a chief solution architect at Ontotext, he'll help us deliver more and more comprehensive analytics. Before we begin, a few housekeeping items. All attendees are going to be on mute to avoid any background noises. You're welcome to ask questions, but please use the question and answer panel and not the chat. At the end of the webinar, Jem will devote some time to answer your questions. But if due to time limitations we cannot answer them today, we'll follow up with an email and responses to your questions. Today's session is being recorded and will be sent to all who have registered and available for viewing from the Knowledge Hub section on our website. Thank you all for participating today. Jem, the webinar is all yours.
Hello, Jem here, Chief Architect at Ontotext. So today's presentation is about dynamic semantic publishing, what the platform is, and how it's evolving. And the agenda for today is who's using DSP approach, how can you and I get hold of it, make use of it, how we've extended the dynamic semantic publishing platform at Ontotext to include recommendation, how recommendation services work, and how they allow users to provide related content and high engagement, and how we've also improved the search capability within the DSP platform. If there's any questions, please make sure that you drop them down in the question section, and I'll try and answer them as we go along. So, what is DSP? DSP is a way of using linked data technology, graph databases, search engines, and APIs to automate the aggregation and publication of content, understanding what that content is, within a knowledge graph, repurposing it within that knowledge graph in order that you can navigate through it, understand it, interrelate it with other content within the scope of a domain model. So past examples have been the BBC Sports site or the Financial Times or the IET, and have had domain models that describe the domain that they're operating in, and you publish the content within that scope. And it allows people that use DSP to provide a greatly improved user experience, to understand the content better, to be able to navigate through it better, to aggregate it in really interesting ways, and also to provide high levels of user engagement. And that's also improved a lot by providing excellent recommendation services and high quality search. So at a very high level, DSP architecture is like this. It takes in unstructured content in the form of text. We do things like convert video and audio into textual representations, so that would mean transcription, etc. But the textual content comes in an unstructured form, and it gets analyzed via a text analytics platform against the knowledge graph that's stored in a graph database, in this case GraphDB. And the structured reference data populates the knowledge graph in order that the domain's well understood. The text analytics system is coupled and aligned with the vocabulary inside the graph database, in order that you can understand the content within that scope, annotate the content within that scope, and then produce APIs and aggregations within the scope of the domain model. The other thing that is used is the notion of a user. So DSP understands what a user is, and also understands and tracks the events that a user takes when accessing or navigating through content, so that it can use this user behavior or user context to aggregate, recommend, and provide content in context with the user. So there's all these services: content, search, annotation, user events, users, text analytics, recommendation, knowledge graph, as a set of APIs, and they all provide access to a set of semantic fingerprints that are stored in a graph database and a search index, and they're exposed by a whole host of APIs in the platform that allows customers and Ontotext to provide visualizations of that content, so that it makes sense, allows you to reuse it and repurpose it. So the main components within the architecture include content indexing. That would mean understanding the content and being able to search over it via TF-DI index, annotating the content so that you can understand what the content's about, what it mentions, what's located in it, what other entities are in the content. It provides a search capability, so a search index. In this case, we use Elasticsearch. That search index is used for things like recommendation indexes, and also concept search and content search. We have a domain vocabulary, which is a graph stored in GraphDB. Stores the vocabulary that the text analytics service uses, and also the navigation entities across the content. We have components for managing users and events, and we also have a recommendation engine that does contextual and behavioral recommendation. So the main data model behind the system is one of a content vocabulary annotation graph. So the system stores many instances of content. It annotates that content with things that are in a graph, so that those pieces of content are well understood within the graph. So this example shows that a piece of content has been annotated with a mention of Samsung, with a relevance score of 56%, and it has a text position within the content of position 123 up to 142, and it also includes an about of Apple and also Tim Cook. And because the graph isn't just single entities, there's relationships between them. The graph allows you to really understand what the content's about. So it's about Apple, which is a within the computer hardware sector. It's not Apple the fruit. It's about Tim Cook, the person that works for Apple, and it really makes you and allows you to disambiguate exactly what the content is. And that model is stored within the graph database. So we use GraphDB for the storage of all of the data that I've just described, and I'll just bring up an instance of GraphDB now, and you can see the types of things that are in there. So GraphDB is loading now, and you can see here, very high level, is this class hierarchy of the DSP data model. And if we click on, as an example, let's click on mentions. So these are mentions of entities within content. We click on this class representation, it shows all the instances of those mentions. We click on the mention, and you can see that the data model describes a particular entity mentioned within a piece of text. So this mention is about a person. The person in question is Daniel Erst. It has a position, start and offset, and it has a relevance score. And this data allows us to describe the fingerprint of the piece of content. So all of the annotations build up to really give us an understanding of what that content's about. As well as having the ability to invoke Sparkle queries and see the class definitions and traverse the RDF data, GraphDB allows you to see the relationships in the graph. So as an example here, we have, again, mention, the type of relationships and some of the predicates that it has. So if I click on one of these, you can see that, again, it describes the data model that I've just shown you. So GraphDB is fundamental in the architecture of the dynamic semantic publishing, as it's the hub of the vocabulary and all the annotations of content that are within it. Another major component within dynamic semantic publishing architecture is the natural language processing pipeline. We use a open source framework called Gate with some extensions, and the extensions are the key part of the architecture. So the standard Gate components like language detection, part of speech, etc., are made use of and extended, but some of the key integration points into the graph would be we have a gazetteer that links directly into the graph database, so that it means that when we find labels within the text, that we're actually referring to real identifiers and entities within the graph, so that we can then disambiguate. So we can, for example, if we find Apple and Tim Cook within the graph and they're quite close in the graph, we can disambiguate that we think it's Tim Cook, the CEO of Apple, and not Tim Cook, the footballer, as an example. The sentence structure of the content also helps to disambiguate. As well as disambiguation and the gazetteer, we do relevance ranking. So we order the found concepts within the pipeline so that we know how relevant they are to the content, allowing us to provide a decent semantic fingerprint and index so that we can find stuff correctly. Once we've got those suggestions out of the pipeline via an API, we also then annotate the content normally via a moderated process, so that editorial or others can select which ones of those suggestions can be applied to content. They're then stored into the content model that I described earlier, so that the content is well understood. Here's an example of a rendition of concept extraction, so I'll just click on this. This is a showcase application that Ontotext have built, and you can see here that this article is about Apple within the graph. It also mentions Samsung, Tim Cook, and Steve Jobs. And if we hover over some of the extracted entities, you can see the type of entity that it's found a person. It's also found the relevance and confidence, and all of those annotations are stored against the content. Each one of those annotations has types so that you can understand the type of relationship, and there's also the ability to filter out the results in terms of precision or recall. So standard F-score type precision recall bias. You can filter them out by type, so those get removed from the extraction. So they're the fundamentals of how the platform works. It's all about a graph. It's about a domain model. It's about concept extraction, entity extraction, machine learning, and gate pipelines that are linked into that graph, and a set of APIs that expose that data to be able to reaggregate and use that data. So who's using this type of approach in the wild? As an example here, so the BBC used GraphDB and concept extraction to build their website, and you can see here there's a aggregation around Chelsea Football Club. All of the assets that the BBC produced are sent through, extracted, tagged in this case with Chelsea, and then aggregated onto the Chelsea football page. There are other examples like the Financial Times, or here's one here, the IET, who classifies its content in a similar manner. So these articles are not only tagged, they're also classified in the pipeline and have controlled entity recognition. So it's a standard approach to creating content aggregation, understanding content, and reusing it and repurposing it. And it's been used by many publishers. So how can you get hold of DSP? DSP is available on premise, so you could deploy it on your own kit. You could deploy the graph database, the search indexes, the APIs, the text analytics pipeline, the ETL, or you could deploy some of it on your own kit and use some of it on the cloud, or you can use all of these services on a SaaS provided platform on the cloud. And send your content in, get it analyzed, get it extracted, spawn out annotations, and reuse the APIs for your own purposes. The DSP platform comes with out-of-the-box domain models and entity extraction pipelines. We have one for news, which I've demonstrated, which makes use of one page. Apologies. Makes use of a linked open data representation. So we use something called FactForge, which is a good representation of the linked open data cloud for general purpose. So we have within that data set, we have people, organizations, locations, relationships between those, standard generic entities that are used within the pipeline. Again, this is a graph DB instance with this data in from the log cloud, as well as the generic out-of-the-box model. We also have specialized pipelines and data models. So we have one for business and finance used for clients such as the Financial Times. We have life science pipelines and data models. We have and do build custom pipelines and data models for specific use cases, and DSP can be extended fairly easily to new domain models and new entity extraction pipelines. I think there's a question actually. There's a question about semantic fingerprint. So a semantic fingerprint is basically, I'll get onto it slightly later in the slides, but it's a ranked set of entities against a piece of content, which enables you to score or find or index that content so it's well understood. It's basically a TF-DI index over a vector of entities associated to a piece of content. Well, I have a slide on that later on, so I can come back to that question. So we're also in the process of thinking and building a fork of the Gate product, so that we have our own flavor of Gate, which will mean that those plugins and extensions that we have developed will become made available, slightly easier to use than just Gate plus some of the plugins that Ontotext have provided, and they will be extendable with domain-specific NLP pipelines and plugins and data libraries and language rules, for example. So let's talk about recommendation, because they're the things that have been extended recently in the Semantic platform. Why do we need recommendation? So the reason for having recommendation with the platform is the ability to serve content that's really relevant to the user, to the context of what they're reading or their behavior. So understanding who the user is, what they've read, what the content that they've read is about, what their peers read, understanding them from a persona point of view, and then giving them related content with respect to those things, so that you can provide good products that are which provide really high engagement and give content that is really specific to the user and not just to the content. So the main components of recommendation are understanding the relevance. Sorry, I can't speak. So relevance with respect to the context. So when a user is reading a particular piece of content, that content has a well understood semantic fingerprint, and therefore we want to show and give the access to other content that has similar index semantic fingerprint on the index, which would then allow you to show and provide related similar context content. We also want to provide the ability to use the user's history, so that's contextual similarity and also behavioral similarity. The freshness of the content is also very important. So how fresh the content is also a boost on the recommendation. And popularity. There's two flavors of popularity. So if the content is popular among the peer review users that user is interested in, and then it becomes part of that user's recommendation through a sort of collaborative filtering scheme. And also we make use of an approach similar to PageRank, but it's called RDF rank. So the weight of the content within the graph, so the number of annotations for that piece of content, or the number of inbound links to particular entities, give you a RDF rank or graph rank that allows you to give or boost the content popularity, so they can make the content more relevant to the user. So how does DSP do this? It takes the content in. It does concept extraction and entity detection using the pipeline I was talking about earlier to suggest the concepts. We have an API for that, so I can show you that quickly. Let me just get, so as an example, let's take in, I don't know, let's take a BBC article. Make a request. Oh, I need an accept type. And the same APIs that we were talking about earlier will then respond with, they'll do an extraction on that piece of content from the BBC, and it will find out what all the entities are within it, so that we can then understand what that piece of content is about. So as an example, it's mentioning here Ray Wilkins. We know who Ray Wilkins is in the graph. It has an identifier for Ray Wilkins, and it has a role. The role in this case in the piece of text is manager, and the results will contain a whole host of suggestions of what entities are in the content. There's a whole host of responses. So let's just see what the content is to make sure that it is about Ray Wilkins. It probably does mention it. I'm sure he's in there somewhere, but yeah. So the API for suggesting content is available as a platform service. You can push your content in. It will then return what we think from a text analytics point of view that content is about. It returns results in this manner. So I've already explained that. And once you've got those suggestions back, we then need to annotate and create a fingerprint that describes that piece of content. So we then pick and choose those mentions within the text that we want to annotate that content with. That might be based on the confidence and relevance score. It might be moderated or might be automatically applied. But the set of entities that content's about and the confidence and relevance scores all add up to create a fingerprint that describes that piece of content from a semantic point of view within the graph. So it means that the content is well understood and could be searched, found, and re-aggregated. So this is just describing what the model is again. So when we annotate the content resides within the knowledge graph and it has relationships within the knowledge graph. So content might be about Apple, it might be about Tim Cook, and it might mention Samsung, and it's also located in the UK. And because it's not just those single entities, though, Apple has a relationship to Tim Cook, the CEO, and it's in within industry, computer hardware, and it's on the exchange Nasdaq. The content is much better understood, and you can navigate through the whole graph to get content that also sits within the graph. So the content might be about Apple, but you might want to show content that's very recent content that's on the exchange that Apple's listed on. Well, the graph allows you to do that. It allows you to query the graph in context of the graph. So I've already shown you content annotation, so I think I'll skip that slide. But the fingerprint is basically a vector of the top-end concepts weighted with their scores within a search index that allows us to then find those pieces of content based on the entities that we found in the concept extraction pipeline, but in a searchable, indexable manner, so that it's very, very quick to find similar content and find them within the search paradigm. So this is contextual recommendation. It's basically fingerprinting all of the content that's in the database and being able to search for those pieces of content that have a similar fingerprint, allowing you to then recommend content only on the contextual context. It's not just about contextual recommendation. I'll just show you an example of contextual recommendation first. This is an article. It's been tagged with all the things that we found about it. So there's a person with a role, it's got an organization, but it also has built up a fingerprint of all the entities that are in the content. And it's then done a search based on that fingerprint to find all of the related content that have similar have semantic fingerprints. So this is how we recommend related content based on contextual entity detection. But like I was saying, it's not just contextual recommendation that's important to recommend. We also make use of user. There's an API for contextual recommendation like the other. Other services, I can quickly show you that. So here we have the API, and we can put in a piece of content, and let's just do that now. Make the request, and I need to first put in a auth code, otherwise this won't work. Let's try that again. And the API now will, based on the fingerprints, return all those articles that are similar in nature. So if you wanted to use the recommendation service as a SaaS service, you could make use of that yourselves. Let's go back here. So like I was saying, also DSP that doesn't just understand content, understands users. So we have the notion of user in DSP. We capture information about the user, so where the user lives, what they might be interested in. So if they're interested in Apple, we can recommend content based on what they're interested in. But we also might capture what, other things about them, like where they're employed, what company they're employed for, and using that data, you can then recommend content based on the knowledge of the user. It's not just the knowledge of the user, so the first-party captured data about the user, it's also about how the user interacts with DSP. So whenever a user interacts with DSP, there are events captured. We have an events API that captures the event that happened on DSP, so the user and the type of event, and we keep a historical profile of that user. And that historical profile of the user then allows us to build another fingerprint, but a behavioral fingerprint. So the types of behavior that we capture might be a view or a follow, a scroll, a dwell on a piece of content from a DSP point of view, but we also understand a user in the context of the social sphere. So we can capture a social behavioral. So when a person views a tweet or follows a particular user, we can use that behavior within DSP to understand and recommend based on social behavior just as much as a user. So sorry, there's another question here. Let me just have a look at that. Could you show the content annotation you just skipped? Yeah, I'll come back to that at the end. If you remind me, I'll give you another example. User history. So we have an API for user history. If you wanted to understand what a user has been doing as he interacts with DSP. So let's use my Twitter handle, and we should be able to see a small amount of history of what I've done in the past. I'm sorry, I need to log in again with the auth code. Let me just put that in. Okay, so this will give me a list of all of the things that I have recently read. So it looks like I'm interested in Russian environmentalist stories, which is quite interesting. Yeah, so just shows you that the APIs in DSP also allow you to capture, reuse that history and get hold of the behavioral context if you need to. So yeah, this is describing behavior recommendations. So we create a profile of a user as he uses the DSP system. Every piece of content that he reads has a semantic fingerprint with the entities that are included with their confidence and relevance scores. And as those content reads aggregate, the summation of all of those entity scores are summarized into a fingerprint for the whole profile of the user. That allows us to then to do recommendation based on a user's interaction with many numbers of pieces of content, and also the pairing of users that they're interested in. That's how we do behavioral similarity. So we combine behavioral and contextual similarity to give interest in recommendation. But the behavioral recommendation has a few components to it. So we have a static historical fingerprint of the user as they go through the use or read content. We build a transition matrix. So we have a matrix that describes how a user transitions between particular pieces of content and what entities are within there, so that we can track those entities within the content are a particular value. We use popularity of the content, so how popular a piece of content is across all of the users or the peer group of users within DSP, allowing us to do collaborative filtering, again improving the recommendation, and also making use of the freshness of the content, so that also boosts and can boost the recommendation back to the API user or the UI user. So I'll give you a little example of what a behavioral and contextual recommendation looks like in a UI. Oh, sorry, it's the wrong link. We'll go back. Let's just bring it up on here. So I'll log in, I'll sign in my Twitter account, and we'll take a look at this article. It's already loaded, that's good. And you can see here the related content here is being served from our recommendation engine, and you can see it has contextual boosts and behavioral boosts and freshness boosts. And these related content are based on the context of the story, so all of the fingerprint that describes this piece of content, but also the behavior of what I've read and what content I've read, and the historical profile that I've built up as I've gone through the content, and also my social profile. And we can change these boosts to see that context, behavior, and freshness have will provide different recommendations, but within the algorithm. So we can tweak those in real time to then allow you to make behavior more important than context, or freshness more important than behavior, and then get recommendations based on those boosts. So and it enables you to, if you're using the API or building a UI, to make use of those boosts within your API calls. Again, yeah, we have an API obviously for this as well. So I'll put in my Twitter ID. And again, we can put in we'll put in the same content ID as I had before, and I'll make sure that I've got the key in this time. So try that again. Oh, I want to show you the key. Okay, so these are based on my Twitter ID and my user profile and the semantic fingerprint of that user and the content as a context. It's coming back with a set of recommendations of content that is recommended, and lists the content ID etc., etc. Allows you to navigate those and reuse those. And you can also put recency in, sorting, filters, etc., etc. as part of the API call. Yeah, so DSP also mines social behavior. So it's not just events from DSP, it's events from the social, from your social activity. So we can mine Twitter as an example and create a social profile and build that into a user's profile to recommend based on those types of events. If you log into DSP the first time, what it will do is it will connect into your social network. It will go through the graph, look at the tweets, extract the tweets, create a profile of what you've read, what the tweets are about, what your peer group is, and then build a profile based on that from your Twitter sphere as well as DSP. So you can bring in behavior from not just the DSP platform but from other sources, and that can be aggregated and added into your profile. So this is a social feed. I'll just show you a social feed. So let me log back in using my Twitter ID. And if we go to the home page of Now, you'll see that this feed here is built for me personally. So it's based on it's all based on recommendation. It's basically building me a recommended set of content from all of the content feeds that come into this platform, and doing recommendation based on behavioral recommendation from social and DSP interactions, and then building this recommendation feed for me. So it basically allows you to cut down through the large noise and breadth and depth of content that's out there, and target content that's very pertinent and related to individuals or individual pieces of content. So how does this increase engagement? So DSP understands content within the scope of a knowledge graph, which means that you can search, aggregate, and recommend content based on its similarity, and understand where it sits within the graph and the entities within it. We also understand the user and how the user sits within the knowledge graph, so that you can recommend content based on, for example, we might want to recommend content based on the fact that you're in a particular industry sector and you are a CEO, so that we could recommend all the content that's in the system that is talking about a particular industry sector that a CEO peer group has been reading. And we also make use of user behavior and social behavior to do behavioral recommendation. And all of those things combined allows us to create a recommendation that's which is highly tailored and increases engagement and makes the content very much tailored towards the to the user and the context. So as well as recommendation within the DSP platform, we've also improved how we do search. So we use a mechanism in the DSP platform called graph rank search. It's a little bit like how Google does page ranking, but it's around the entities within the graph. So as the number of inbound annotations to an entity occurs, so in this case we've got, I don't know, 4 pieces of content that have been annotated and tagged with the entity Frank Lampard. We then obviously boost that entity within the graph because the RDF graph weight is much higher, which means that we can boost the search index based on that rank. We also know that within the graph index that there's multiple Frank Lampards, and there's actually multiple Frank Lampards that are football players, but they're different because one Frank Lampard is was playing for Chelsea Football Club recently, and one Frank Lampard is actually his dad, who's retired from football and isn't mentioned very much in the news. But based on this graph ranking mechanism and data model and index, we can then provide search that is more tailored to the content and entities that are used more within the graph. So I was describing, yeah, within the LOD data set that we have multiple Frank Lampards, but we know that the Chelsea football Frank Lampard is mentioned a lot more in the graph and mentioned more in the news, and therefore when we search for Frank Lampard, he is more favourable than his father, who has retired and is no longer playing football. So this is what a graph rank search would look like, perhaps in a UI. So let's go to search. We can search for Frank Lampard. He's already added, and the demo is not working right now because there's no content on Frank Lampard. But I've just added 2 instances on this search, so it's a multi-entity search, and it's including those things that are about Frank Lampard and Jose Mourinho, but it uses the graph ranking to serve those concepts to the user first, and it also allows us to do some faceting. So given that we're searching on Frank Lampard, the football player, we're also going to show those things in the graph that are also football players that are mentioned quite a lot within the graph, the people, and then you can also show the organisations that are related to those entities, the locations and categories for those people. So the graph allows you to do show some faceting, intelligent faceting, but also show search results that are more pertinent based on the usage profile or graph weight within the graph database. Yeah, again, DSP is a service offering, so we have an API. We have an API for it. I could do a quick search here. We can see here. I'll have to log in again. Let's put up. Lampard. And this has now done a search on our search index using the RDF rank, and it's now come back with those things that we think are associated to Frank Lampard. So Frank Lampard is the first thing, and then obviously those things that are related. And each one of those things in the search result has a resource identifier that also can be used to find the entity within the graph to describe Frank Lampard and its relationships in the graph. Yeah. So there's a search service, and there's an example of results, which I've just shown you in the API UI. This is a concept search, so this is basically showing you the concept that was returned in the search and more details about that particular entity. So the ID that was returned for Frank Lampard in the search service is you can then query and find out about Frank Lampard and understand who that person is. So we've queried the concept API with the person ID, and it's come back with Frank Lampard, a description, the types of who that person is, the URL, etc., etc. And there's a whole host of other data and other relationships for that entity within the graph, so that you can understand who that entity is, or what that entity is, and how it sits within the domain. Yeah, so we have extended the concept extraction service so that we don't know just about single entities, but we can also model entities and their relationships to sub-content within content. So as an example, I'll show you a relationship that shows a person making a quotation. So let's make that call now on the API. Get. Again, we'll use the BBC article I used before. We'll do concept extraction using the entity extraction pipeline. hopefully within the results. Oh, let me put accept header in. Oh. Hopefully within the results you'll see some responses that include relationships. So the first one, luckily, oh no, that's a person role. Oh yeah, here's a quotation here. So we have a mention here, which is a relation organization. So an organization is mentioned within a quotation. So the extraction pipeline is able to detect quotations within the text and who or what the quotation is about. And that it's not just constrained to quotation subtypes, it can be extended to other types and other relations. This is just an example. So that type of rich relationship extraction and sub-content identification is returned in our API, but it also allows us to do to show those within a UI. So as an example here, we've got relation, person, quotation within this article. The annotation types that we list within our content are not just single entities now, so we can turn all those single entity types off. But you can see relationships and sub-content type relationships within there. So here's a quote that we found, and here's a person role. This is a person as role as president, which is nice. But we can also use that data to search. Oh, I've got another question here. How do you input the API key? So the API key is just a header, which you can pass. It will be sent over HTTPS, so it'll be encrypted. The reason you're seeing it in the Swagger API is because it's just a simple way of putting that API key. But yeah, it's just a RESTful HTTP header. Right. So yeah, back to the presentation. Sorry. So we have relationships. We have sub-content types. We can annotate those. We can understand those. They can be part of our fingerprint, but we can also search for those things as well. So our search index allows us to search for sub-content types and the relationships. So let's click on this as an example. This is showing all of the quotations that are about Putin. So there's a number of those, and we can pick one of these. Let's pick this one here. And the quotation will be mentioned in here. We can also search for those as well. So we can search by thing, and we can also search by quotation. So Vladimir Putin is one. Let's search for quotations about Vladimir. We've already done that, so let's take that off. Let's do quotations about Donald Trump, and hopefully that will return. And then you'll see that we are able to search for sub-content types within content based on the annotation that we found a particular quotation by Donald Trump. And you can see all of the Donald Trump quotations here. So there's a number of different types of quotations. So we've got about and by. So the quotation is either about a person or is quoted by somebody. And the model of rich entity relationship annotations and sub-content types is fairly easy to extend and is all searchable. Yeah, so there's an API for that as well. I'm probably boring you with the APIs, but yeah, there's another question. How is your knowledge graph language agnostic, or does it work on specific languages only now? It is entirely language agnostic. So we have the RDF model can have as many different language labels as you like for a particular entity. So if we modeled, I don't know, Apple, we could have as many different descriptions of Apple in any language we like within the graph. Our text analytics engine uses that vocabulary for its extraction, and therefore can find and understand all of the different language labels for that entity. And our concept extraction pipeline also understands and detects language. So when a piece of content is pushed through the entity pipeline, it can determine that it is a particular language, and therefore use particular language rules or particular labels within the vocabulary. So yeah, that's all possible, and we have examples of different languages implementations if you wanted to see those. Yeah, that's all doable. We have Japanese as an example. Yeah, lots of different languages. That's all doable. Right, so quotation search API. Yeah, the quotation search API, I think I've done APIs to death, but yeah, there's an API for searching for quotations as well. Right, so I think I covered everything I was going to cover in the presentation. Hopefully, I've covered all the new advances in our DSP platform, and you can understand how search and recommendation work, how all of the services are available via APIs. They can be deployed on the cloud or in your own infrastructure or reused as a service. How the architecture works, how our text analytics, extraction and annotation works. And I hope I've given you enough of an insight and taster into what the semantic publishing approach is and how Ontotext deliver that to some of our clients. And if you have any questions, please do add them. And if you don't add them now, I can get back to you and answer them by email. So there's a question here. Is there an opportunity for gaining some experience, a lot of interesting features? We have to think about how we can tailor these functions for supporting communities and communication, interaction, reflecting the activities and knowledge creation, learning as a community practice. When you ask, is there an opportunity for gaining some experience? Yeah, we can do follow-up sessions. WebExes, if you want more information. We can share papers on how the architecture works, or the APIs that are available, or how you might extend it for different domains. We could potentially come and visit you and understand your domain and see how it will work for you as a client as well, if that's something you're interested in. So yeah, do reach out, send us an email, and we'll most definitely let you know how it can fit in with your particular use case. Any more questions? Oh yeah, there was a question I had to come back to, I think. Could you show the content annotation you skipped? Yeah, I can definitely do that. So let's go to the home page. Let's pick an article about Galaxy S8, the new phone. Yeah, so we've found an organization called Samsung. We've identified where it is in the text. We've given it relevance and confidence scores, so how relevant that entity is to the article, and how confident we are that it is Samsung, the organization. The main things that the content is about is noted on the right in this panel here. The different types of annotation on this UI are shown with different color codes. So we have, is there a location here? Not a very good example. Let's pick another example. Okay, here's a location. We found China, so we understand that that's a location, and we know it's China, the place within the GeoNames dataset, so that we know where it is in respect to the geolocation. We know that this is an organisation, University of British Columbia. We've got all of the types. You can filter by type, so there's locations mentioned here, organisations, peoples, events, these types of relationship that we found, and the concept extraction and suggestions, we found, can also be tuned and filtered based on precision recall, like I mentioned earlier. So recall, so as many things as you can versus actual precision. So standard F-score modeling, you can filter in real time as you make requests. So you can either have you can either be more interested in precision, or you can be more interested in recalling more and making your own decision. So hopefully I've covered that question about what our annotation stuff looks like. Yeah. There's another question here. Is there something built to deal with the ETL or content, i.e. a REST API to hit with a body of text document, which then adds the document to both the document store and annotates it in DSP? If so, what's the document store used in the cloud offering? Yeah, we have a ETL, a lightweight ETL REST service called Content Processor, and we also have some ETL, heavier weight ETL processes that allow us to transform and then push it through the business logic of doing concept extraction. The document store we use, we store the content in multiple places. Well, we store it in Cassandra for our corpus of documents, but we also store it in GraphDB, and we also store it in our search index. So it's the content stored in multiple persistent stores, not only a graph database. So hopefully I've answered that question. There's another question. I'm a medical translator. Is it possible to use these services in the cloud? Yeah, most definitely. We have all of the APIs available in the cloud. It's possible to submit content and get concept extraction as an example. Yeah, I guess it would depend on your use case, but all of those APIs are most definitely available.
Thank you, Jem, very much for the insightful talk. Thank you, everyone, for your questions and attending today. If you have still another questions, please write to us at events in Ontotext, or just reply to the emails you have received about the webinar. There are still some unanswered questions, but our time is finished for today. The webinar has been recorded, and together with the presentation will be available in a few days. I would like just to say a few words about our upcoming webinar the next month. It is a live online training. It will be about designing semantic technology proof of concept and help you deliver a successful project for a business use case. The course will be held on the 27th of April, Thursday. It includes 9 teaching hours plus 1 hour individual consultation, which is optional. And until the end of April, we have an early bird price with 50% discount. We hope to see you in our next live webinar, which will be about FactForge, which Jem briefly mentioned. FactForge.net is a hub of linked open data and news articles about people, organizations, and locations. It offers a public service for free access to data represented as RDF graph, and also includes a live streams of news and metadata linking news to entities and concepts. If you are interested to learn more, join our Executive Director at Annotation next month. And goodbye for now. Thank you again for attending our event.